In the last video, we discussed Newton's third law of motion and net force in one dimension. Now, let's take a look at a couple of examples where we have to calculate the net force in one dimension. We have two sled dogs pull in the same direction on a large sled. One dog pulls with 25 pounds of force, and the other pulls with 35 pounds of force. A frictional force of 45 pounds opposes the motion. What is the net force acting on the sled? Since we are looking at net force in one dimension, we always want to draw a picture showing which forces are acting in which direction. We have two forces from the dogs acting towards the right, and the force of friction acting in the opposite direction. So, we will add 25 pounds plus 35 pounds and subtract 45 pounds for friction. This gives us a net force of 15 pounds forward. The net force is the overall force that the sled feels. In this example, the same sled has a mass of 20 slug, and now we want to find the acceleration of the sled. We will have to think back to the first section in this chapter where we discuss force, mass, and acceleration. Using that equation circle, acceleration equals force divided by mass. We found a net force of 15 pounds in the last example, and here we are told that the mass is 20 slug. We can take 15 pounds and divide by 20 slug to get an acceleration of 0.75 feet per second squared. We have one last topic to discuss, which is equilibrium. When a body remains at rest or moving at a constant speed, the forces acting on the body are said to be in equilibrium. The total net force is zero. This means that the total forces in one direction equal the total forces in the opposing direction. The stoplight in this image is in equilibrium because it is not moving up or down. It is at rest. Alternatively, if we have a car moving along a highway at a constant speed, the car is also in equilibrium, and the net force on the car is zero, meaning the total forces propelling the car forward are equal to the total forces holding the car back. We have one last example that will demonstrate equilibrium. Two men push in the same direction on a large crate to move it at a steady speed across the floor. One man exerts a force of 250 newtons and the other a force of 300 newtons. We want to know what frictional force opposes the men. First of all, notice that we are told that they push in the same direction at a steady speed. Since the crate is moving at a steady speed, the crate is in equilibrium, meaning the net force is zero. Thus, the total forces pushing the crate must equal the total forces opposing motion, which in this case would be only friction. So we can add 250 newtons plus 300 newtons, which equals 550 newtons. Again, since we have steady motion, we are in equilibrium, so the frictional force must be exactly equal to the total force the men are applying. This means that the frictional force that opposes the men is also 550 newtons. This concludes our discussion of net force in one dimension.